Hi, today we'll talk again about Venn diagrams in the context of a specific package ChIPpeakAnno. Yes, it contains own function to draw Venn diagrams, and it is a very special case where the Venn diagram is not based on a list of names, which is usually the case, but on the chromosomal positions of the peaks, and then the program analyzes those positions and decides which peaks are in overlap or not. But what if I want to use another Venn package, which I like more? Then I have to resolve an issue how I can use the data calculated within a ChIPpeakAnno and connected to the external Venn. What you have to know is that Venn packages in this respect are of two kinds. One category of Venns does everything in one step, including calculations and the figure, like ggvenn, for instance. You cannot use those. And another kind of Venn packages leave some intermediate calculations or accept already pre-calculated data. Those Venns you can try to attach. And Vennerable, Eulerr and G-plots Venn can do this. You can theoretically try to use them, but then the question is, what can you fit in and out? Inside ChIPpeakAnno lines, as soon as you use this function find overlaps of peaks, it will silently generate a table of overlaps under this extension Venn CNT, which stands for account. And once again it generates exactly the same table of overlaps after you call make Venn diagram, which will show you Venn diagram indeed, but also make another copy of the same table. That's the output format which you can try to use. What about inputs into another Venns? Unfortunately, there is no standard input for Venn diagrams. This format is accepted by Vennerable package. It consists of 3 lines, names, then binary combinations. This stands for nothing. This is for the first group, for the second, for the third one, combinations of 1 and 2, 1 and 3, 2 and 3, 1, 2, 3. And a similar format is you can find in a Venn diagram for lemma, but it's a special case where not included indicated in a line 1, and then again the same combinations ones and zeros encodes what is combined with what, and that's the results. In Eulerr is somewhat different. It's not a table, it's a list of combinations where ABC stands for groups again, and those are the combinations, and these are the results. That's how you can attach potentially those alternative Venns to your ChIPpeakAnno. Obviously, you have to resolve a puzzle how to connect ins and outs in your data. One solution is given directly in a ChIPpeakAnno user's guide. They say if you want to stick Vennerable to your ChIPpeakAnno, then copy-paste those lines and it will work. Let's have a look how it works in reality. I used the very same example again as I used before, taken from this GEC number. It's about IMOPs and neurons. I load the BET files generated before, converted to G ranges. Everything works through G ranges in ChIPpeakAnno. Then, because there are too many, I split it on 2 groups, And now I would select for set of 3 neurons. Alright, the calculations are finished. And now I call the Venn counts, and this is the table. The first 3 columns are those famous combinations, present, absent. And then we see that, for instance, set number 3 alone shows this number, specific only for this set. Set number 2 has these numbers, in combination that one, number 1 alone this one. All the information you need to build up a Venn diagram. And this additional counts is again counts for set 1, set 2, set 3. If you take call sums for this column, then you will have a total counts for every set in separate. So let's use those lines from the user's guide of to connect Vennerable. First, you take this Venn data set out of make Venn diagram. So it's not only a Venn table, but a bit more. There are names and something. And now I repeat those lines as they are recommended in the user's guide. And then it converts all the internal data to this sort of a table of 3 lines. And based on it, you simply call plot, and then you might call squares. Yeah, and here are the squares. But can I use Eulerr package, for instance? It is possible, although I could not make it so nicely as example of Vennerable. I had to call Python for help. I would ignore this transformation for Vennerable and return back to a data frame, which is simply first part of the table counts with names and counts and combinations. And R is stiff and not really flexible to process text lines, yet you can try. For instance, doing this loop, you can generate something like this and then copy paste into Eulerr, where you do the rest by hand. You supposedly should have an end product like this, or you go to a Python, and in Python you can again save and open Venn counts, then get the data line by line like this, and then do replacements once by A in the first column, once by B in the second, once by C in the third. Then the counts are still as there are. Then add necessary quotation marks and a comma at the end. And the end product will look like this, which is a perfect fit to what you want. Then you copy it, go back to R, and do the paste. And the only thing I was lazy about was the last comma. You remove it, the rest is done. And so you call Eulerr, call the fit, format is taken, then you can inquire fit, and it tells that what you will see on the figure is approximation. It's not a perfect fit. There are some errors in sizes of circles, have to know it. And then you plot, and then you have the figure what I showed you at the beginning on the first slide. What I like in Eulerr is Eulerr style itself. You can change it to regular Venn if you like. Also selection of colors and the segments to color. For instance, you can do a yellow background where you had white just by adding these colors. And then if you don't like labels in the centers of your circles, then you can put them aside like this. And then they will appear on the side. And then, of course, not unimportant, you control fonts and sizes, and you add counts and percentages, or one of those, anything you want. To conclude, there are always more possibilities of presenting your results than suggested in any particular package, and the most important part of the package is what is calculated, and for illustrations you can make your choices. That's it, and thank you.